Hello everyone, good morning. So today we have a session on DataBricks part 1. But before, let's wait for 2 minutes. I will go you through Azure developer site. And today is the morning, so I hope you all are fresh and with good mind. Is my screen
For two
visible?
minutes, I will go you
Yeah,
through.
it's visible.
Okay. So Azure developer community is now a good big community which have already like near about 10,000 members, and you can surely here we focus on learning, networking, and upskilling. So you can see that many of the session, if you want to grow in the Azure part, ML part, you can check out the session. You can connect with us from wherever you want, like join the community. And as you want to give the talk like us, you can be a community organizer and organize many such events and be more active in the community. So you can check all the upcoming event, and if you want to be a speaker in our community, surely you can just register and our community will check it out. So you can join your community from here. Yeah. So yeah, Vishwas. So as introducing Vishwas, yeah. So Vishwas is a passionate about learning new technology and meeting the developers and helping and solving the problems which you have in Azure field. So today I will say thanks, and Vishwas, you can start with the database session part 1,
Yeah,
and I hope
sure.
you all will enjoy this.
Yeah, I think perfect. And thank you so much, Vilsi, for giving this opportunity. And yes, let's get it started. So, Azure Databricks has a long history because it evolved over a course of time. How? It's because of the research papers that everybody thought about, like, okay, this is what things were going wrong when we are handling terabytes of data, petabytes of data, and also there are hundreds of things that we want to really consider. And what this paper marked was an history of big data technology. If you go through this, Google had its own problem statement in 2003. Of course, they are pretty old in company right now, but they started evolving, and that's where Google file system came in. Then this gave an architecture in which we are actually talking about, like, how can we take in geospatial data? How can we take in image data and leverage it? Your Picas used to use the same old file system, but Picas is nowhere today. It's Google Photos or else something else. There are amazing photo apps also. So there are a lot of other stuff that we really don't know, but history just repeats itself over a course of time. Whatever you are seeing here, the same concepts just repeats over there. And this is a Google file system, clients, master, and there is a lot of other kernels. And if you remember before, I think before 2013, 2012, 2013, these were the times where VMs were like being used, and that is where these VMs are being talked here. So I think whatever you think of this CMD, Docker images, I think I have pretty images or pretty some of images about this Kali rolling. I think I'll just do this. I think Kali rolling, GHCRS from the GitHub container registry that I just did in the bug session. And there are pretty much a lot of stuff, like, this is an exploit bug bounty toolkit, which is like kind of a Linux, as well as some bug bounty toolkits which are already installed there. And like it's a pretty amazing thing, right? So this is what file system means to me today, because if I just do docker run minus IP Kali Linux and Kali Linux rolling, I'll show you what it is all about. So if I do this, it will take some time. I don't know why, but it will take some time for execution. But if I do ls, it gives me all the file systems which are still there. And if I do ls slash bin, it gives me all the file system, which is actually saying the commands which was already used for running and things like that. So this is what file system means to me today. But earlier days, it was all about like the chunky big VMs which are already there, and which is always taking in huge space and a lot of hypervisor and lot of watchers, a lot of load balancers which were supposed to be designed. And today, if you see, let me just show you how. Today we have something called as an user. So let me just do this user, and there is always this something called as a connected WAF, which is already there. I'll come to what is WAF, what is this thing. So always there about architecting a solution, and always this connectivity will always have an RPC protocol, request and the process communication protocols, and all the things which we are really designing towards. It's all there. So this is what communicates with the cloud. This is also what which communicates with the on premises. And what Google did was they had this user data patterns, and they had this WAF which was already there. Of course, WAF was not there. They had their own security protocols, and they were designing a lot of other systems as well. But let me just talk the real world scenario that we are talking today, which is always about like how can we get this done, get that done, and things like that, right? So cloud can be of any flavor. It can be GCP, Azure, AWS, or a Heroku, or else anything. On premises, of course, there are some curated servers and the things like that. And this is what really means to me today. It's like this complexity of cloud and on premises is just in this form factor, but it's even more complex when we go to something like, it's all about like how do I scale, how do I observe, and how do I monitor. And all these problem statements that I'm talking here about, all this still prevails here as well. So on premises also you have the same thing, and that's where your case study on Dynatrace from, I think this is what I call the amazing case study of building a very good observability platform using a Cosmos DB. Why I'm saying you this? Of course, there is a correlation between what observe and monitoring and things like that are today, but how they are leveraging the Cosmos DB today is actually the same old principle that you see here. The same old file systems which are communicating. There are a lot of handlers, there are a lot of locations which are already there. There are some redundancy build and things like that. It is still there. So of course, this was good enough to actually give a push for the big data. But Jeff Dean and the same guy, the Sanjay sir, always really wanted to really get to know, okay, this is what we really want. And they came out with this something called as MapReduce, and this evolved as something called as Hadoop, and later part it just evolved as something known as Spark. And Spark really gave out that one intuitive thought about like what can data be tomorrow if we are just doing something. So when I look at that paper, it always gives me this one thought process about like what should be my velocity, what should be my variety, and what if I have too much of volume. So variety, velocity, and volume is similar here because we all have that desire for getting a near real time and real time processing. So near real time and real time processing is like the most desired architecture that you really want to build for tomorrow's world, because a lot of times when you think of something which is like you have a patient who is like somebody like, let's say he has an heart condition, let's say there is an sigmometer, or else something like pulse oximeter. Yeah, let's just oximeter is one such sensor which will be streaming in data in the real time. So this scenario works really fine there. But a patient can't be just monitored by using one sensor. So there are a lot of varieties of data set which will be coming. Like it can be real time SQL data set, like query data sets, CSV file, images, and also can be some sort of a text. If you think of something called as precision medicine, this is what you work towards. This is what you work towards. And volumes are something which is very deliberately talked about, because a lot of times when you have something like variety, there are hundreds of parameters that you can really design towards. But I would say volume is another part of it, because you don't have to just think of something like GIFs or something. It can be like megabytes of data, gigabytes of data, kilobytes of data. Of course, kilobytes of data makes a huge difference when you are talking your company's infrastructure being utilized at every second. Like every second, if it's giving, like let's say a calculator, calculator. Oh, not camera, not camera. It doesn't work. So calculator. So it's here. So let's just do some quick math. So 1 kilobytes of data is 1,000 bytes, and 85,000 seconds is something which we talk about, right? So it will be this much, and this much amount of data from one person. Just imagine if you have millions of users, what will be the scenario out there? And that's where Jeff Dean really came out with this kind of a paper. And this paper really talks about the types of the data, the way in which the user interactability can be increased. And also, there are a lot of uh, IoT based concepts which are also talked here, but it's not emphasized here. So there is a lot to be talked about. And if you really want it, you can follow these guys. Sanjay came out with, oh my god, amazing papers. Just go get as many papers as you can from this person. He's an amazing scientist, by the way, a truly an amazing scientist. So you guys can check it out. Like this is a Google Scholar link for. All right, so don't worry. So just go to this paper on Google file system, and also this MapReduce paper. If you Google it, it will be there in front of you. So it's a no brainer. So Jeff Dean, one of my biggest and the greatest inspiration for the big data, and there are pretty amazing scientists and scientists behind the RESTnet and everything. So you guys can go check it out. But that comes in the ML flow part. We don't talk about that here because we are basically focusing on how to leverage this. So what happened next was, and Stanford scientists got really pissed off about, like, the installation of the Spark is very difficult. I'm not even joking. If you want to really install Spark, just get in and install Spark bare hand, bare metal. It's impossible because every OS has their own dependencies to be installed and things like that. And also running it on the real time, that's a huge task, because sometimes Scala just works absolutely good on some places, but also it has its own uh, it has its own trade-off with the environment as well. So that's always there. So what Matty does is, he's one of the best profs, and he's one of the founders of the DataBricks, and an amazing person in terms of the big data technology. His publication speaks actually. So 2012, when you look at some of the papers that you're talking about, the shark, the resilient distributed system, because that's what really gave an motivation for starting DataBricks. And this paper, what I'm talking about, is truly unimaginable expectations which will be covered because of your distributed systems which are being talked here, and also about how to leverage a database. Your NoSQL, SQL DB doesn't matter until and unless you're not build the resilience. So this gave a chapter of resilience to all the people. And when the Azure started like 2008 something, I think it never had some sort of a resilient system and things like that. So later on, all these features are being added. So I'll even show you how do these resilient features and everything being added there and things like that. So I think whether you study other paper or not, but I want you guys to study this paper. This is one of the best papers that you can look at, and this paper is basically saying how to leverage that Hadoop infrastructure that we had by using something called as Spark. Spark Hadoop has the same genetics, but yet they are different. So that's what we are talking about. So in a meanwhile, if you want to really understand what is going on behind the Spark research, you can go here and check out what is happening in the Spark research. And I'm not joking. DataBricks has some amazing white papers, and I think Azure DataBricks, both of them which were there. I think I missed it out. No, I have not missed it. So three practical use cases of Azure DataBricks, and this is also one of the uh, white papers. And I'll make sure that after the session it will be there in the comment section down there. So don't worry about anything. You don't lose any of the things. But I would say just go back to this white paper stuff, because I would just say that like reading white papers are like the truly unimaginable expectations getting covered. And also scaling Spark, I think this is one of my favorite paper. When I started learning about big data like 1.5 years ago, this was the paper that I really wanted to work towards. And there are amazing toolkits. Like, you need not have to worry about you don't have an Azure subscription. Community DataBricks, you can just hop in here, log in, just start working here. So it's no brainer. You just can get in, start working with any of the infrastructure which is available here, and it works absolutely fine here. Like, I'll even show you. It has all the machine learning, machine learning, as well as the data engineering aspects covered, and you need not have to worry about like what can be the next big thing that I need to be working. So if you have too much money, just make sure that you also upgrade it, because spending money on this kind of a technology doesn't mean you're losing, but you're basically gaining a lot actually. So just go there and check out. And I think these two white papers, killers, just read it. Just read it. I can't explain everything because a lot of times when we are in the session, we just have to cover a lot of things. So we just rush out. But like sometimes if you want something more, just reach out to me back. And this Spark engine basically talking about the performance, utility, and everything. So if you think of something like this, so Michael Lambert, one of the best researchers in the Spark industry, and it's in a MIT CSAIL. So MIT has a lot of research in the big data. So anybody who is an amazing professional in the big data can enter MIT. So that's no big deal. So there are a lot of network layers and the things like that. Why we are talking about it? Because when you create an Azure Databricks or any Databricks platform, so let's just say a Databricks platform, and what you are supposed to be delivering is and file system configuration, config. There are also NSG, network security groups. NSGs are something which are always there in any of the application. If it's on cloud, there is an NSG. And there is something called as a VNet. Why? It's because there is always that one interaction that goes on behind connecting all your services and keeping the security much more secure. Like, you need to be more secure for the tomorrow's world, or else everybody takes a control of your system and things like that. And also, Databricks has an additional requirement, that is monitoring and source control. What we talk, the same GitHub, the same MATLAB, and all the things that you uh, really leverage towards, right? All these monitoring that I'm talking about, the source control that I'm talking about, Because earlier days when you see Databricks professionals, they were supposed to code and they were supposed to forget the fact that even the other developers has to really write the same code. So there was a person in an organization who used to write a lot of optimization codes and things like that. But monitoring and source control became one of the leveraged aspects, which is nothing but DevOps culture. This is a culture. It's not a subject, or else it's not about how the organization needs to work. It's a culture at the end of the day. So it supports DevOps culture. So let's just leverage that. So there is always a file config, there is always an NSG, there is always a VNet that is always connected and things like that. So if you think of all these, this is what it talks about. So this is the paper that I love to share with you guys, because this is the paper that really gives you that leverage. And also, if you go here, it's all about like contributing article, but this is an upcoming Spark and unified engine for the big data processing. How is it? This is being told here. And also, delay scheduling is one of the things that we'll be taking on with respect to the security as well. So, if possible, before the part two, learn this because it's going to help you a lot. It's going to help you a lot because I learned a lot of things from what is the scheduling aspect all about. And it's not the scheduling that you do every time, but it's the scheduling which you do in order to stream the data, store it somewhere, batch it out, and then process it. So this is what the paper is all about. So that's it from my side. I think data frames and all this, everything will be there in the comment section. Just go and check it. But some of the amazing courses here in MS Learn is this. So I would say just go, just get in this course, because this course is truly a good course and it covers all the basics. I actually do a little bit more here because we are supposed to give a lot of other tools and technologies as well. But if you're an absolute beginner, this is the place you can get in. And also there is a lot of things. So Dynatrace, observability platform, how they are leveraging that Cosmos DB stuff, mind-blowing research. Actually, amazing case study from Dynatrace on Azure. You guys can go and check this out. And there is no match to any of the case studies that I've really read. Of course, this is a smaller one, but it has a huge impact on what do you think about observability and monitoring in the tomorrow's world. I think Xbox is also doing great, but it doesn't have that thrill that you get from the Dynatrace that I have been saying. But Xbox is really good, so you guys can go and check it out. So yeah, I think let's just come up with some code now, because a lot of times when we think of these trainability and the things like that, it's a really worst aspect because we don't get to know what is Azure's role in all these, because Azure has their own infrastructure which is like, hey, I'm just drawing hundreds and thousands of flowcharts and I'm just writing all these and whatnot. So you can connect with me in any of these platforms and we can have a healthy discussion. We can also have a lot of discussion actually. So feel free to connect with me, and do feel free to connect with me on my podcast. So I do a lot of podcasts with amazing researchers from different fields. So recent love DevOps. So I'm doing a lot of DevOps actually. So you guys can really get in. So in machine learning, we have categorized it, right? So at the end of the day, all of these things that you're talking here are run with respect to data, and how to do a data engineering before all this is what Spark talks about. So Spark, or any platform that uses a lot of data engineering and the things like that, it's all about data modeling and the performance tuning that you're seeing here. It's nothing better than what you can expect, because all these things are just the expertise that is required, but at the end of the day, data modeling, performance and things like that are very important. And a lot of times this is what DataBricks is all about. So DataBricks has already had their own leverage, but Azure and the Databricks is and much more ease of connectivity towards all the Azure platform. This is stream analytics, data factory, Power BI. You can also do other sort of Synapse Analytics or cognitive services. There is Kafka streams, there's Hadoop, SQL, data lakes, Blob storage. I'll be showing Blob, and I'll also be giving a case study on how this Cosmos DB is also leveraged here. But Cosmos DB is another session because it comes in a part 2 or part 3. I still don't know, but let's just do that. So now it's all about scaling. So let's just come up with our own scenario because a lot of times it's all about scenarios. So let's just get in. So of course we know that there is a network security group and things like that. So let's come up with this scenario. Okay, let me just say I'm a car owner and I have bike and a parking lot. A parking space. Let's say parking space, not a parking lot. Like it's not there in most of the Indian places. So parking place. So we have a bike and we have a parking place right now. And now what you have is probably something like, I can say my room is 7 and 10. Probably let's say it's like 10 cross 10. That's the space here. So 10 cross 10 is 100 square feet. And you have this 100 square feet of land, and your gadi, what your car is 800 square feet, something, let's say square feet. So your bike is 150 square feet. And now let's say you have a bike which is always running, which will be always parked on the road, but your car is supposed to be there. And now how do you leverage this 150 square feet of land? You can rent it to some person, or else you can say to your neighbor or something, just use this space, I don't use it or something, and things like that. So, and you will be having an extra 50 square feet for walking. So this is what I'm talking about. This is a typical scenario in every middle class family that we have this problem. All right. So we have this and we are just running it and we are just leveraging all these aspects. So now what happens is you have a mall, you have a contract with a mall, you have 100 hectares of land. Okay. Hectares of land, and you have a contract with a mall. And they say that we need a parking slot. What if you have a car which is 1,000 cross 1,000? Of course, Hummer is much more bigger. Like you can say, it's an exaggeration, but like you can say something like 1,000 square foot of car only, like probably 1,000 square foot of car. And how can you put it inside? And now it's not about that. You also have to do real time monitoring of the spaces. And there is amazing case study on how to even leverage this as well. So what you do is you have a set of data which is some sort of a pattern, like of course 1,000 square foot cars are something like uh, it's an abrupt vague analogy, but there is even bigger cars or else a smaller car, who knows that, but something like 20 car setting. And you have a lot of small cars which are coming up. So what is that space that is required? How many cars went in? How many cars didn't move out? Or else how many hours of cars have been like parked and things like that? So it's all about that. So what I can say is, when we go to this portal or something, we will show you how to even leverage that as well. So before that, let me just go and introduce you this Spark environment. So I think that would be great because a lot of times when we think of DataBricks, it's not about Spark itself, it's beyond that. So let's just do that. So If you just go and search it here, so this is where your DataBricks come in. So what you do is create a new one. Just create a new one. There is always that one way in which you can create it. Mine is a pay as you go model. And what I do is I have a DataBricks demo. Let me just do that. And look at the fact that there is already a network RG group, network watcher resource group, and the data groups are G, which is already being created. My resources in this folder, but my other resource groups are there in the other folder. I'll even show you what that is. So what I drew here before, uh, here, what I drew here is what you will see there as well. So Vishwas Narayan demo. Sorry, what is this? So this is Vishwas Narayan demo, not Northern University and something like you can use South India as well, but I would say keep it in a prime position. So it's better. I think it's validated. Click on create, it will create and it will take some time. So instead of that, what you can do is you can go to directly for a created resource and you'll get the same old environment here. So what I'm talking about, this virtual networks, it's not being there, but I'll show you how it's also there. So if I go to the resource groups, and this is my Databricks resource group, which is default created by Azure itself, and everything that you're seeing about all the JSON views and the subscription ID and everything. So deployment of two succeeded, perfect. And if you see network watcher RG, there is always that network which is always created. And if you go to this, and if you see the task previews, if you add a task it will just get added. It's like I'll even show you how to create a jobs there, export the template. You can export it as it is if you think of the variables and things like that. So a lot of times when you think of some uh, engineers who are in the database world for a very long time, they talk schema. This is what your schema is all about. It's just a set of JSON which is controlling the compute resource. And you can manipulate this, like you can add a lot of other resources as well. But let's not touch it because I too don't know many of the things, but I know how to leverage it. Workspace. So I think what you get when you launch this in the overview section is this entire thing. It will ask you for a sign in with an active directory, and it will always have this own default stuff. And of course this is one of the environment. When you start, none of the notebooks will be there, only this and this will be there and this will be there. And what you can do is you can just click onto the data science and engineering. Machine learning is also there. If you want, you can also check in with this auto ML and the Databricks thing that we did with Vilsi. It's an amazing session there. So what you can think of as create, there is always this create tab which will say notebook, tables, cluster, job. So notebook is something which is as good as a Jupyter notebook, which is always there. So a table is something as good as a data set. So what you can do is you can upload it. So let me just say this is the better option. So this is here. So create a table, and if you click on this, it will open a new tab which will say, okay, this is what is required here. And it was saying, okay, this is where your file is being stored, this is where you are supposed to be working. Of course this is working fine, that's perfect. So it's connected right now. So if I just run this, it will start running all the file systems. So what you are seeing here, he's from an Azure DataBricks DB. So DataBricks DB file system. So DBFS is Databricks file system. What you're seeing is absolute working of the Databricks file system. How is the file stored, tables being stored, and the things like that. So I will come to the Spark jobs and the other things later. So don't worry about that. So I just create that table. If you want, you can create a cluster. It's very simple. I have a quota now, but you can't run that quota. So cluster demo, I just do that. and I click on the create option, it will start creating, it will allocate me the resources. What you see at the end of the day is this green dot which should be running, and there is always the two nodes which are already been working. There is one notebook which is already associated with it, and this is what I'm talking about. So I can terminate that. I don't want that to be created. I'll be deleting all the resources, so don't worry about that. So right now we have all this, and what you can really do with all these is go to a workspace. If you want, you can import a workspace, or else you can create one. So I always love to create one, and I just did that. And this is what you see. Spark is very useful in order to give you that leverage. How? It's because it already has that way of working. Like, it's like, you know that this is going to work for 10 days or 20 days, but how is it going to work? And this is what it is. So if I just create the cluster, it will always be there. So don't worry about that. So that command, everything is sorted. So what I did was I had this find spark, there's find spark in it, and what it's just doing is it's just asking for a spark session to be created and things like that. So this is what your Python demo is all about. So as you know, it's like very complex. This is a topic on its own for an hour, so don't worry. I'll be sharing you guys the notebook in this website. DataBricks by Vishwas. Yes, this is my website. So if you guys go to this notebook section here, there is already a lot of other notebooks that I have uploaded here. So what you can do is you can go back to all the things that you really want to learn. And also, I think I'll be removing this and this because already my life is very complex and I don't want that to be even more complex. So that's what it is. And I think this is my YouTube channel. Do subscribe to my channel and also listen to my podcast, which I always do and I always love to. And yeah, like that's what it is. So don't worry about that. That will always be there. So just go and subscribe and things like that. So I've done everything from Python, PySpark, and everything. So this notebooks will be added to as well. So don't worry about that. So this is Python. This is R. I think I need to show you this SQL, but I just use a magic function here. I'll show you what this magic function means to you tomorrow when you're doing an research using Databricks or something. So something like I'll say this is a Spark notebook cell that you're talking about. And what it has is, and as you know, it's an interpreter. So it's an interpreter, it starts executing one line after the other. So what you are leveraging is all the interpretable language through a magic function. If you put percentage SQL, it goes and compiles the codes as an SQL. If you type in percentage R, it compiles as the R programming language. If you type in Scala, take in a Scala. If you want, you can do Java as well. So Java is also being supported because your Spark ecosystem has this. Everything what you see here is leveraged using Java itself. If you want to know a fun fact about Scala is also a part of the Java as well. But Scala is not that effective because community didn't have that much amount of support and not many libraries came in and things like that. Whatever you're seeing about the stream processing, graphics, the MLlib, machine learning, Spark SQL plus the data frames. Damn man, I think I have not made a good move here. Oh, sorry. So sorry for the typo. So all the things that you see here, the Spark, the data frames, everything, it's been written using Java itself. So at the back end, it's all Java, but what you see is a Python, PySpark interpretation. That's it. So it's still a Java. It still has its own perks and things like that. So and I just did that, and also what I've done is the train model and things like that. And you can really leverage all the things that is there here because everything is being told to you is always there in one or the other way. So if you look at this, data.read.csv. This is an R syntax for reading CSV and printing it. Of course, I'm doing that. And I had a plot function, but I just deleted it off. So that's not a big deal. And this is one of the Scala interpretation where I did with RDDs, Spark context and Spark sessions and things like that. So RDD and Spark is something called as resilient distributed data set. So what you are seeing here is an interpretable aspect, but I would love to show you one more. Wait, it's here. So I want a Spark job. So this is what I'm talking about. So what you're seeing is an absolute functionality of monitoring, but this is very complex. This is not what we require. And all these are something like, okay, there is some sort of an function which we are taking care of. There is always a standard mode of operation. There is one console which is throwing in the data. It can be as good as an IoT device, but what you see, monitoring here, every places that you are seeing monitoring, it requires a lot of monitoring because it's very dynamic. And designing hefty system takes a lot of time, and this is what we are talking about. So when you have a standalone mode system which is always like, I execute one thing, then I go to the second thing. It's not like one and two being parallelly executed. It's never going to happen. So that's where your standalone systems are being considered. And even if I do hundreds of cell run at one time, it runs one cell after the other. So that's how leveraged your DataBricks are. So what you are seeing here is also a part of the Spark job as well. So I can show you one Spark job. I think it's here. I think yes, it's here. So a Spark job is here. So if you look at that, so, oh, it's because I didn't connect the cluster, but that's fine. That's not a issue because what you get is the same old thing. Okay, this is what the data is, this is what the plot is, and the things like that. And that's what it is all about. And if you go to the advanced version of the other stuff like SQL, only some SQL demo, but I'll show you one complete SQL demo because we have very less time now, and I need to even give you a Synapse Analytics and Spark data house and things like that. So let's just do that. So wait. So table commands. All the things will be command complete there. So demo complete Spark SQL. So what I did was just this adaptive environment here. So what I did was the same old thing. So what I am asking is, hey Spark, I need an adaptive enable. So you need to be adaptive for any of the changes that is going to be dynamic here. So that's what I'm saying here. And if you look at some of the older codes, I'm just creating an SQL table. SQL is very easy to be created, and this is what I have done. And adaptability, of course, this is going to be the king here because SQL is known for adaptability. How? I'll say you how. So you have an SQL compiler or an interpreter here. So it's called a structured query language. Right? So it's all about that. Okay, you are just passing in some queries and it's being executed one after the other, or else according to your needs, it just gets executed. It can be both parallel and the serial runs, or else anything. Like it can have conditions, it can have loops, it can have any amount of commands that can be executed. And there is lot, so that's where your Spark SQL DBs are there. So if you want, you can just plot all these with these functions as well, and also you can download it as an CSV file, and you can see that. Like I'll even show you how this is. So it's there. So it's still a CSV comma separated value file. So It's all with the delimiters. So what you do with the delimiters, so this is what it is, the delimiters that you're talking about. And lot, man, when you think of all these other functions, it's always there. So explaining all of these functions will take a lot more time. So what I'm doing is I'm rushing down to the other things like Spark jobs and the things like that. So if you do, I think probably this will not appear, but yep, it's appearing. So what you are seeing, the same old Spark jobs is being listed down here. So it's all amazing in order to get to know. I think I ran it very long ago. I think it's there. I think. All right. So submitted. Oh, 2029. Yesterday night at 8 p.m. I think so. Yeah. So that is what your Spark job is when you see through the Spark jobs profiling that is already there. So if you go to my other sessions, there is Spark UI, which is already being considered, and you can go and check that out. And you go and check this tabs here. It also gives you the same thing. So all about the notebooks is this. You can leverage any amount of language. Scala, R, Python, SQL can be leveraged here. And you can also results only, sidebars and view edits and everything are there. And you can have a lot of other stuff. So you can import the data set, export it as HTML files. Of course, I'll be doing it as HTML files and I'll be giving it to the world through that website. And I think that's it from the DataBricks point of view. But this is what your notebooks are. And if you want, there is something called as revision history. There's experiments which are also considered, which is like Spark experiments, no runs, because I have not enabled any of the experiments through the ML workflow. So that's why there is no experiments here. So ML and everything comes in the later part. So there's always this revision history. If you do this, it's just about like what you didn't do, what you did, and all the things which were changed will just come up here. This is what versioning is all about, and this is what you do with the GitHub connections. So save now and things like that. Of course, it will always be saved, so don't worry about that. If you want, you can delete it as well. So if you just go check this box here, you can delete that option as well. But there's nothing to delete because it's all about like working with the real time scenarios and things like that. So that's what it is. So and that's the one. So connecting to the blob storage, I'll say you why we need that, because this is what the code is. First see the code, and now even though I have a lot of Spark queries, I'm just creating some sort of a queries and I'm just throwing it. And this is what I did. What I did was I had a storage account name, I had that, had a storage account key, I have that, container name, I have that. I'll show you where that is also. So if you go here, if you go to the storage accounts, where is my storage account? It's not storage account. So it's here. So if you go here and check out what is my, so that's my new storage account name is Vishwas new. That's what I did. And my security keys, events, if you want, you can draw some functions and you can start working here. And access key is here. So if you guys go here, this is what your access key, just show the key and you can start working. So that's what it is all about. So this access key, everything starts working. And afterwards, what you have to do is you have to go to the containers, create a container, add a name like demo ADB something. It's now created. And what you have to do is you just have to get in, add the name of the container. There is something called as an access key policies as well. So if you add some access key policies, there is some shared access tokens which is already there. So if you want that, you can do that, but I would say don't do that because it's already there in that environment. So if you are going away from that, yes, you need that. But if you don't want that, don't do that. Whoa. Oh, okay, fine. I don't want the revision history. Get out. So now this is perfect. So dfutils.ls, this is the one of the ways in which you can connect to it and you can see what's the file there. And if you schedule it, this is not running because I think 11.7 I stopped the containers which were running, but you can see how to run now, how to do this, how to do that. do that and of time and as well. I think nothing wrong happened here. Perfect. Because my computer has gone through a lot, so that's why it's always there. So yeah, that's what it is all about. So it's all about like you have this much amount of compute resource, how to leverage it. So what you do is you connect it with the Spark or the Blob storage. So I'm emphasizing more on this Blob storage, Cosmos DB, and the things like that. It's a it's a no-brainer here because what I will be showing you is a data mesh architecture. Where is my data mesh? Yes, it's here. So perfect. So guys, what you are seeing right now here is a typical data mesh architecture. This is according to my learning, but there is even advanced ones which are already built as well. So this is according to my learning. So I think probably next paper that I'll be writing, it's basically on this. So, so there is a data source which is always from an application DB, public cloud, on-premises device, and there is always an data center DB which is always there. So it's all connected through an internet, and there is always this software-defined networks, APIs, and application deployments. There are amazing summary data, raw data, and metadata which will be classified using a data warehouse. I'll explain you what data warehouse, data lakes are all about for the tomorrow's world. And what you do at the end of the day is you just throw that data out for the deployment. And this is what we are talking about. And this is not available for every little architecture because you need to know where your architecture stands. And this is where you get that understanding of, okay, this is what my architecture is. And there are data catalogs, there are data dashboards, SaaS application, analytics application. There is amazing stuff. So you guys can go check that out as well. So let's just come to address what is this data warehouse and things like that. So what we are talking right now is a data warehouse, data lake, and there is an data store which we always talk about. So this is what it is all about when you're considering some sort of an architecture in order to store all your data. The big data that you're talking today is all about being storing all these data set in one place. And what it is all about today, so it's all about like when you consider Azure, it is all about let's just write it off. So when you consider Azure, it's all about Cosmos DB, which has a lot of other API connectivity as well. There is DataBricks, and there's SQL DB. There's an SQL database which is already being enhanced, and it's always working here and there. And it's like you have some sort of a queries which is already there, and that is storing in. It is always about semi-structured data. I think structured data can also be there, and semi and structured. STRUCTURE, structured and semi-structured data. So structured and semi-structured data is one of the key ways in which you can leverage all the data sources which are already there. So that is what it is all about. So when you have an SQL DB, it's something which is to deal with structured and unstructured or the semi-structured data that you're talking about. And what they are is always about like handling something through a blob storage, because blob storage has that flexibility of connecting to any of the data sources. Like you can have multiple streams of data in it, and this is how you leverage a blob storage or a data warehouse. And this is what it is, and that is where your blob storage comes into the picture. And if you talk in more advanced terms like data factory and the Synapse Analytics, let me just grab those two images as well. So Synapse Analytics, data warehouse, perfect. Let me just grab those two. So let's come to Synapse Analytics at the end. I think I can share that same thing here. I think the same image that I'm talking about can be used as well as here. So let's just do that. So copy that, paste it here. So what I'm talking about is this. So there is always this Spark SQL and a Spark database, and what you can be seeing here is an additional factor that is here, data factory. What is this data factory all about? So data factory is having all the services which is attached to it. Something like Azure DataBricks, Cosmos DB, Blob storage, everything is through an Azure Active Directory interacting with all the things. So what it does is it just uses the leverage of the Spark, which is already being present in all the big data architecture, and now it streams in all the data, stream and process. That's what it takes care all about. So at the end of the day, if somebody asks you like what does this do, what does that do, it just does nothing. It just does stream and the processing. But in Azure Data Factory, there is a lot of things to be monitored. Like everything has to be monitored, everything has to be taken care. So typical Spark kind of an environment is being enhanced as a data factory, which has its own things like, okay, this is what the architecture looks like, and this is what I want to do. And what Stream Analytics does is simple. So let's just minimize this and just go to the Stream Analytics. So simple as that. What Stream Analytics has is it brings a lot of leverage of big data and the data bricks on the table, but easy deals. That's what I'm talking about. So let's just address the fact. So you have some sort of a data source, and there is always an ingestion of the data. That is what you do. That is what ingestion is all about. You just put in the data sources, and there is always that real time processing. What Synapse Analytics does is, since it has all the things like pipelines, data transforms, stores, data stores, and there is always this leveraged repository. I'll show you what is that leveraged repository. It's not there, but we are just adding it because we just want to make the explanation much more easier. So it's like you have a pipeline which is already running it. So you can connect GitHub, AWS Redshift, Impala, and also Kafka streams as well. So when you have all these, you need to have a versioning of all these. So that's where I'm talking about this leveraged repositories, where it's actually making the versioning of the data sets, which is always about like, okay, I have this much amount of data, what next? If I have more amount of data, how to do that? So what I'm talking about, this, what do you call the data mesh, is always about versioning of the data, training the model and in the real time and the things like that. So this is what it is. And also versioning of the code, because versioning of the code is something which is always an headache for all of us, because when the pipeline changes, there is always a new behavior that is always monitored and addressed, and that's what your Azure Synapse brings to on the table. So it has everything that is already supposed to be leveraged, and what it does is it just makes sure that you are just having the accessibility and the connectivity right, then you have everything to be achieved. So that is what Azure Synapse is all about. So if you ask me at the end of the day, what would you choose about whether Data Factory or the Synapse Analytics? I would happily go and choose Synapse Analytics, because a lot of times this is what they really mean to me, because it's all about like how can I deploy my model away from the Jupyter notebook? This is what my solution is today. So I think we covered pretty much everything. I think there is nothing, but I want to say one more thing, because why my compute clusters are not being created like one after the other, one after the other, because there's always a service quota for everything. So there is always a virtual CPU quota which is already there. So single node, because I have already been running two nodes and one of my clusters, so of course the four virtual CPUs will obviously be gone and things like that. So that is what it is. So the notebooks will be there in this website. So just go and check this. So after the session, I think I'll try to do that. If not, I'll try to get it as quick as possible. That's it. That's what your DataBricks is all about. So don't make it complex. Learn it as easy as it is. Like, it's already being leveraged. It's already being packed into one form factor here. You just need to access it. Of course, you have to throw in some money. If you can't throw in, don't worry. There is a community edition of that as well. Where is it coming? What happened? I think this is going to work good. Yes, I think. Sorry. My computer undergoes this a lot of times. I don't know why, but yeah, it undergoes somehow. So yeah, that's what it is. So just go and just grab the notebooks, start working, because everything can't be spoon fed, because we are all working professionals somehow, and we all will be there. And all the things that I've been talking about, all the links will be there in the comment section after the session. So don't worry about that. So I think that's it from my side, folks. And thank you so much for being in the session. I think too many documentation. Next session there'll be no documentation. It will be more of Azure itself, because this is what I really wanted you guys to have prerequisites before we go on to the further sessions. I think this is the end of the most theoretical session. So that's it from my side, folks.
Yes, Vishwas, thank you so much. The session was amazing. And I would think that folks will be really waiting for the second database session. And yes, folks, that will be on 15 on same channel. So you can subscribe to the channel and get that notification, or else you can join the meetup group or anywhere you can get the notification of that. So on 15, it's 6 to 7, right?
Yeah, it's 6 to 7.
It's
Yeah,
6 to
that's what we
7.
have planned.
Yeah. So and third session will be on 22. But yes, you will get the notification. So don't worry for that. So yes, Shashwash, thank you so much.
Yeah, thank you so much, Vilsi. Thank you so much.
Yeah. Okay.